Unit rates. Write several rates equivalent to 11 miles per gallon. So I'm going to write the rate that we're given, which is 11 miles per 1 gallon. And if I want to come up with an equivalent rate, then I just have to make sure I'm multiplying the top and the bottom by the same number. So let's try 2. If I multiply the top by 2 and the bottom by 2, then the rate that I would get would be 22 miles per 2 gallons. Now you can also go the other way. So if, let's say I multiply the top and bottom by 5, and I get 55 miles per 5 gallons, I can also divide the top and bottom by the same number. In this case, I'll make it 11. I'm sorry, I'll make it 5. And then I'll get 11 miles per gallon again, right? So as long as you're multiplying or dividing by the same number on the top and the bottom, then the rate that you're going to get is always going to be equivalent to the one you started with. All right, so now let's look at a unit rate problem. My family walked 4/7 of a mile in 4/11 of an hour. What is our unit rate in miles per hour? Okay, so let's start off with the rate that we're given. It's 4/7 of a mile in 4/11 of an hour. So that looks a little complicated to have a fraction inside, actually 2 fractions inside of a fraction. So we're going to use the fraction bar as what it's intended to be used for, which is to represent division, right? So we're going to write this rate as a division problem. So we're going to have 4/7 divided by 4/11. Now, when we divide fractions, we're going to keep the first one, switch to multiply, and flip the second one. The 4's will cancel because 4 divided by 4 is 1. So I'll get 11/7. Now remember what this means. This is 11 miles in 7 hours. Now, that's better, right, than what we started with, but it's still not a unit rate. And the reason it's not a unit rate is because in order to have a unit rate, the denominator must be 1. So the only way that I'm going to get this to have a denominator of 1, if you look at it like we did on the other page, is to divide, right? I want this to be equal to something over 1, which means on the bottom, I'm going to have to divide by 7. So on the top, I'll have to divide by 7 as well. So 11 divided by 7, I have it here, is 1.57. Let's say we'll round it. It's a repeating decimal, so we'll round it to the hundredths place. 1.57. So the unit rate would be 1.57 miles per hour. All right, let's try another one, another unit rate problem. Here we've got a comparison of different size cereal boxes. One is $1 more than the other, but one has more cereal than the other. So let's take a closer look at the labels to see which one's a better buy. So here, this one is $5.69 and I'm getting 17 ounces. This one is $4.69. I'm only getting 12.25 ounces. So let's see which one is the better buy. The better buy means that we're finding the cost per, and then whatever it's measured in, grams, ounces, liters. So in this case, ounces, right? Cost per ounce. So in order to do cost per ounce, or anytime you see that you want a rate expressed as something per something else, it's always the first one divided by the second one. So we have $5.69, right? That's the cost per 17 ounces. So that means we have to do 5.69 divided by 17. When you do that, you're going to get 0.335. So that is 33.5 cents, right? Let's look at the other one, and that would be per ounce, right? Now let's look at the smaller box. For the smaller box, we have a cost of $4.69 for 12.25 ounces. So when you do 4.69 divided by 12.25 on your calculator, you'll get 0.383. So that would be 38.3 cents per ounce. Now, if we round them, because we don't want decimal approximations, I guess, it's the first one, 33.5, would round to 34 cents, right? And 38.3 would round to 38 cents. So you could still see the difference even if you round them. But if we're looking for the better buy, it's going to be this one, right? Because it has a smaller cost per ounce. Now, believe it or not, they do show you this in the stores. So this is what the full label looks like from the shelf. And we can see that they give us the unit price, 33.5, right? Or 38.3. And that's the cost per ounce. And you can see the little cent sign behind it, right? 33.5 cents per ounce, 38.3 cents per ounce. Sometimes it looks like this, right? They tell you how many ounces you're getting, what the price is, and then they give you the unit price. They don't always give you the unit price, which is why it's good for you to know how to find it so that you can be an informed consumer and get the better deal. All right, one more unit rate problem. A cheetah's maximum speed, and actually this is supposed to say, let me just fix it right now. There we go. A cheetah's maximum speed is around 1/60th of a mile per second. What is this rate in miles per hour? So let's start with the rate that we've got. So 1/60th of a mile in 1 second. All right, so suppose we want to know how fast this is per minute. If we wanted to know per minute, then that's 60 seconds. So just like we saw in the very first example, as long as I multiply the top and bottom by the same number, I'll have an equivalent rate. So in order to get a 60 down here, I'd have to do 1 times 60. So I'd have to do times 60 on the top as well. So here's what that would look like. 1/60 times 60 over 1 would give me 1, right? So on the top, I will have 1 mile. So this cheetah goes 1 mile in 60 seconds. Another way I could write that would be 1 mile in 1 minute. So now I can easily find out how much that would be per hour because I just do that again. An hour is 60 minutes, right? So once again, I'm going to multiply the top and bottom by the same number. I'm going to multiply by 60 on the top and the bottom. And then on the top, 1 times 60 will give me 60. So another way to write this is, oh, this is miles, is 60 miles per hour. Or what you'll see a lot of the times is MPH, 60 miles per hour.